Welcome back. This is an Aleks training video on understanding periodic trends in effective nuclear charge. Sounds worse than it is. The nuclear charge is the effect that the electron has from the nucleus. The nucleus is positive, and it's exerting a pull on the electron. And so that pull can be affected by the other electrons near it. Okay? So let's imagine that I have a positive, okay, like a big positive. Let's say that's 10 positives or whatever's in the nucleus, so 20 or whatever that electron, the atom happens to be. If I have shells, so the first shell would have 2 electrons, the next shell would have 8 electrons, the next shell would have 8 electrons or whatever like this. The electron pull here, if I have an electron here, and this pull that the nucleus is making on the electron, well, these inside electrons are shielding. It's making that pull a little less pulley. Okay, so these are called shielded electrons. These are shielding this electron from the full effect of the charge. The thing you have to keep in mind to do this problem is the other electrons in the same shell doesn't shield it very much. Okay, doesn't shield it hardly at all. So what that means is if you go across the period, every electron in the outer shell is feeling a little more pull of the nucleus as it goes across, because the very last shell, those last shell, the ones that are in the last shell with it, the valence shell electrons, are not shielding it. Okay, so let me give you an example. Here is, let's say I've got sodium. Sodium is positive 11, and it's got, so it's going to have 11 electrons. It's going to have 2 electrons plus 8 electrons plus 1 electron. Okay, so the next one after sodium is magnesium. Magnesium is going to have 12 protons. It's going to have 2 electrons, and then it's going to have 8 electrons, and then it's going to have 2. Okay. Let me go further on down. So let me do like sulfur. Sulfur is going to have 16 protons, 2 in its first shell, 8 in its next shell, and 6 in its outer shell. Okay, now look at the difference. This electron is feeling the effects of 11 pulls, 11 protons pulling on it. Now it's shielded a little bit by these guys, okay? But what you're going to see is these are shielding it. Well, so are these. They're shielding it the same amount, but these guys are changing, but these guys in the last shell don't shield each other very much. So as this number gets up from 11 to 12, there's more of a pull on each electron. As it gets up to 16, there's more of a pull because this number is going up. This number is going up also, but these last valence shell electrons aren't shielding it from the force. So as you go across the period, you're going to get the effective nuclear charge is going to go up. Okay, so let me give you a couple definitions. Z is going to be the nuclear charge. Okay, that's going to be 11 or 12 or 16 or whatever the nucleus has. The effective nuclear charge, okay, is going to be whatever Z is minus whatever the shielding is. So that's the shielding. The shielding effect is the same as you go across, because whatever that is, all of them on that row is going to have the same inside electrons. So this Z star, or the effective nuclear charge, what you're looking at, is going to be whatever the protons are inside the atom minus whatever the shielding is. Okay, so let's look at the periodic table. All right, so I have a periodic table here, and we're looking at the following atoms. We want to know scandium, we want to know manganese, we want to know cobalt, and we want to know iron. Okay, so rank them in lower to higher nuclear charge, effective nuclear charge. And remember, as you go further across towards krypton, you're going to get more and more and more pull from the inside. Okay, so scandium would be the lowest, cobalt would be the highest, and then manganese would be number 2, and iron would be number 3. Okay, so that's exactly what you're looking at here. Scandium is going to be the lowest. Okay, so scandium would be the lowest, and cobalt would be the highest. Then I don't know. If highest is 1, then this is 2. And this would be 4. That would make that 3. You understand, you're just putting them in order. So I hope that helps.